This conference will now be recorded.
Hello and welcome back. My name is Viv, and today's topic will be tubular maximum and renal threshold. Yes, we are talking about the kidneys today and how it relates to diabetes. This video is made for students in higher education, so knowledge of biology and chemistry will be needed. Let's jump in. First, I want to recap the nephron anatomy and how the kidneys filter blood. Then we can get into the definitions of tubular maximum and renal threshold. While we typically think of the pancreas as being a major player in diabetes, and it is, since that is where insulin is produced, but the kidneys' roles in blood glucose is also just as important. Finding glucose in our urine can be serious, so we will be discussing diabetes mellitus. We will end by looking at a recent article that studied glucose reabsorption between type 1 and type 2 diabetics. As part of the urinary system, the kidney's role is to filter blood and remove waste or excess from the body in the form of urine. Additionally, the kidneys conserve salt, help produce red blood cells, maintain the body's pH, maintains water balance, and eliminates foreign compounds like drugs, pesticides, or additives from our body. The kidneys are two bean-shaped organs located between the abdominal cavity and the back muscles just above the waist. The renal artery supplies the blood, and the renal vein sends it out. Once the blood is filtered, the waste travels through the ureter to the bladder and out through the urethra. Men have longer urethras than women thanks to their sex organs. Within the kidneys are the renal pyramids where the nephron is located and filtration takes place. The smallest unit of the kidney where filtration is happening is called the nephron. The glomerulus, a labyrinth of capillaries, separates the proteins, amino acids, ions, red blood cells, white blood cells, and platelets from the blood into Bowman's capsule. This capsule is a collection bowl that surrounds the glomerulus. The glomerulus is considered leaky because of fenestrated endothelial cells, allowing the materials to move between the capillary and the capsule. About 20% of the plasma is filtered in the glomerulus, amounting to 47.5 gallons per day, about 65 times the amount of blood an average person contains. The material is moved from the capsule into the tubular system of the nephron. Once entering the capsule, the filtrate goes through the proximal tubule, starting in the renal cortex of the renal pyramid. As the proximal tubule lowers into the renal medulla, the oncotic pressures increases, causing water and other materials like glucose to be reabsorbed by the peritubular capillary. The filtrate then enters the loop of Henle, where the oncotic pressure gradient is the greatest, and descends to the distal tubule. This is where ions are reabsorbed through the decreased oncotic pressure. The pressures within the tubule could be their own video, but it is important to understand that the osmotic pressure gradient within the renal pyramid is what helps to reabsorb substances. After entering the distal tubule and back into the renal cortex, the filtrate is dropped into a collection duct and is sent to the bladder. The rate at which the glomerulus filters and the mathematics behind it could also be its own video, but for our purposes, it's best to understand that the glomerular filtration rate is the total amount of filtration between both kidneys, considering the surface area and permeability. If 20% of the plasma is filtered when entering the glomerulus, on average, we are filtering 125 milliliters per minute of plasma. Within the plasma is glucose, or sugar, which has a concentration of 100 milligrams per 100 milliliters, meaning 125 milligrams of glucose enters the filtration process every minute. If glucose concentrations in the plasma doubled, we would see 250 milligrams of glucose pass through the glomerulus. The tubular maximum is the ability for glucose carrying mechanisms to reabsorb the most amount of glucose possible, maxing out at 375 milligrams per minute. On average, we are nowhere near our tubular maximum for glucose. But what if I can't use the sugar in my body and my glucose concentrations rise? What if I have type 1 diabetes and I can't produce insulin to let my body use the glucose? Or if I have type 2 diabetes, or the insulin I do produce, I can't use? To combat excess glucose, especially in diabetic patients, glucose will be filtered out and excreted via urine. Once we begin seeing a substance in the urine, we have reached the renal threshold. This means that concentrations of the substance have reached tubular maximum and needs to be excreted. The renal threshold for glucose is about 300 milligrams per 100 milliliters. If our plasma glucose concentrations are 450 milligrams per 100 milliliters, well above the average amount, with 125 milliliters being filtered per minute, this means 540 milligrams of glucose is being filtered, much more than the maximum concentrations allowed at 375 milligrams. This means 165 milligrams of glucose per minute will then need to be collected by filtration and excreted from the body. Diabetes mellitus is when we begin to see glucose in the urine, as the insulin our bodies produce hinders cellular respiration and does not allow us to use glucose properly. Glucose begins to be filtered out of the body as our kidneys deem the excess glucose as waste. The kidneys do not regulate glucose concentrations, it only allows a certain amount to enter back into the plasma. It is the same with all plasma nutrients. The kidneys simply maintain what has been established by other organs. In a new study out of Japan, researchers compared the effectiveness of sodium glucose cotransporter 2, SGLT2, and inhibitory medication between patients with type 1 and type 2 diabetes. SGLT2 inhibitors do not allow for renal reabsorption of glucose in the proximal tubule, forcing glucose to be filtered through the urine, helping those with diabetes to lower their blood sugar concentrations. One of the ways to measure the effectiveness of SGLT2 inhibitors is through the HbA1c test, which measures how much glucose is attached to hemoglobin. Patients with diabetes usually have an HbA1c of 6.5% or higher. In the United States, SGLT2 inhibitors are not approved for type 1 diabetic patients. Therefore, the research coming out of Japan reflects the need for comparison of SGLT2 inhibitors as new medicines for type 1 diabetes are becoming available. 33 patients with type 1 diabetes and 62 patients with type 2 diabetes were asked to arrive with an empty bladder to collect blood and urine samples once a month for a year. The researchers measured blood glucose concentrations and HbA1c levels from the blood sample and urinary glucose levels from the urine sample. Type 1 diabetes patients were on average 30 years younger than those with type 2 diabetes and had lower blood pressure and body weight, though all patients were of the same ethnic group. In previous research, researchers determined that those with a high renal threshold, their minimum amount of glucose to be reabsorbed is still pretty high, reacted better to the SGLT2 inhibitors. Those with low renal thresholds often excrete glucose in urine even if concentrations of glucose even if concentrations of glucose in urines are still low. In this recent study, researchers determined that those patients with type 2 diabetes had a higher renal threshold than those with type 1 diabetes. Since the renal threshold is lower for those with type 1 diabetes, the researchers saw normal reabsorption of glucose and, compared to the type 2 diabetics, had lower reabsorption. The researchers concluded that these inhibitors do not affect type 1 diabetic patients as they would type 2 diabetic patients, since their lower renal threshold allows for glucose to leave via urine more readily. Located between the abdominal cavity and back muscles, the kidneys are two bean-shaped organs that filter the blood of waste and excess materials to be excreted through urine. While the kidneys do not play a role in regulating blood glucose concentrations, it does take excess glucose and excretes it through urine. The tubular maximum of glucose in the kidneys is 375 milligrams per minute filtered back into the plasma. Above the tubular maximum, we reach the renal threshold, where the difference between the blood glucose and tubular maximum is positive and can be detected in the urine. Studies show that in patients with type 1 and type 2 diabetes, that the renal threshold of glucose is greater in type 2 diabetic patients. In an attempt to lower the blood glucose, sodium glucose cotransporter inhibitors are used to reduce the plasma concentrations of glucose. Studies show that patients with type 1 diabetes will not benefit greatly from the inhibitors as type 2 diabetic patients based on their low renal threshold. Thank you so much for watching and have a great rest of your day.
This conference will now be recorded.